Let's talk about what happens this time if we change the number that is inside with the x. We know that if we put a number in front of sine, right here, that's going to change the amplitude. That's going to tell you how this thing is going to stretch vertically. But let's see what happens when I have a number with the sine x. So right in here. So really this is half of x. So I'm going to start just by putting values in. I've already graphed sine of x. It looks like this. Notice it has a period from here to here. So the period is 2 pi. It also has an amplitude of 1 because there's a 1 right here. So it's going from 1 to 1. This one's also going to have an amplitude of 1. It's going from -1 to 1. But something different is going to happen because I'm dividing x by 2. So let's think about this. Let's start with 0. If I have sine of 0 divided by 2, 0 divided by 2 is 0. And if you look at the unit circle as 0, sine is 0. So that point's going to stay the same. Let's think about pi over 2. So I'm going to do sine of pi over 2 over 2. So I've got pi divided by 2, which is really the same thing as sine of pi over 4. So if I think about my unit circle, that's going to happen right here. And sine at that spot is square root of 2 over 2, which is the same thing as approximately 0.7. So when I go over to pi over 2 this time, it doesn't go all the way up to 1. It just goes up to about 0.7. If I think about pi, if I go all the way around to pi, so I have sine of pi over 2, that is right here, which is 1. So it takes all the way over to pi to get up to 1, as to where before it was just, it went up to 1 at pi over 2. So let's go ahead and think about 3 pi over 2. So I'm going to have sine of 3 pi over 2 over 2, which really becomes 3 pi over 4, which is right here. And sine at 3 pi over 4 is square root of 2 over 2, which is 0.7. So here we're kind of starting to come back down. So let's think about 2 pi. If I do sine of 2 pi and then over 2, I just get sine of pi. And sine at pi is 0. So what happens this time, and I'm not going to keep going through it, but this would be -0.7, this would be -1, this would be 0.7, and so on. The graph is going to look like this. So it's taken this black curve and stretched it horizontally. So now from the start to the stop of my graph is not just 2 pi anymore. It's just a half of it. So it's going to take all the way over here to 4 pi to make 1 period. So putting a number here is going to change the period. And the way that you can find the period is by using the formula 2 pi over b. So in this case, our b would be 1/2. So when I do 2 pi over 1/2, you flip and multiply, it would be 4 pi. So for instance, let's say I had a graph that said sine of 6x. Well, I know because I have a 6 right here that the period is going to change. It's either going to be stretched or it's going to be squished in. So I have to decide what happens. So I'm going to find the period by doing 2 pi divided by 6, which reduces to pi over 3. So that means the period of this graph is going to be between 0 and pi over 3. So if I graphed it, let's say this is pi over 3 would be somewhere in here. That sine curve is going to go up, down, and come back up before it gets right at pi over 3. So this thing has not been stretched. This one has been compressed. So a number bigger than 1 right here is going to compress it or squish it in. A number that's a fraction right here is going to stretch it out. That's going to change the period.